As the global community pushes toward a more sustainable future, electric vehicles, or EVs, have emerged as a key player in reducing greenhouse gas emissions and mitigating the adverse effects of climate change. While EVs present a promising alternative to traditional internal combustion engine vehicles, it's important to evaluate their environmental impact across the full life cycle, from production to operation and disposal. One of the most compelling benefits of EVs is their potential to reduce greenhouse gas emissions. Traditional vehicles rely on fossil fuels, releasing significant amounts of carbon dioxide or CO2 and other pollutants into the atmosphere. EVs, on the other hand, produce zero tailpipe emissions, especially when powered by renewable energy sources such as solar, wind, or hydroelectric power. A typical EV produces about half the emissions of a gasoline-powered car over its lifetime. The shift to EVs is crucial for countries aiming to meet net zero emission goals. EVs are significantly more efficient than internal combustion engines. They convert over 77% of the electrical energy from the grid to power at the wheels, whereas conventional gasoline vehicles only convert about 12 to 30%. Less energy loss means lower operating costs and reduced strain on resources. EVs also support regenerative braking, which recovers energy typically lost during braking. Despite their operational advantages, EVs are not without environmental challenges. The production of lithium-ion batteries, the heart of EVs, involves mining raw materials like lithium, cobalt, and nickel, which can be environmentally destructive and energy-intensive. Mining processes can result in habitat destruction, water pollution, and high carbon emissions. Ethical concerns exist around labor practices in regions where these materials are sourced. Efforts are underway to address these issues through battery recycling programs, sustainable sourcing initiatives, research into alternative materials, and solid-state batteries. The environmental sustainability of electric vehicles also depends on what happens when their batteries reach the end of their useful life. Improper disposal can lead to hazardous waste concerns. Second life applications, for example, for energy storage, extend battery usefulness. Recycling technologies help recover valuable metals and reduce the need for new raw materials. Proper waste management and circular economy strategies are essential to minimizing environmental harm. Electric vehicles contribute to cleaner air, especially in urban centers plagued by traffic pollution. Reduced tailpipe emissions mean lower levels of nitrogen oxides, NOx, and particulate matter, PM. Improved public health outcomes, including reduced respiratory illnesses and cardiovascular diseases. Cleaner air translates directly to healthier communities and reduced healthcare costs. Electric vehicles are a critical step forward in the global fight against climate change and environmental degradation. While challenges exist, particularly in the areas of battery production and raw material sourcing, the overall impact of electric vehicles is significantly more positive than that of their fossil fuel-powered counterparts. As technology evolves and sustainable practices become more integrated into the electric vehicle life cycle, their environmental footprint is expected to shrink even further. A collaborative effort among governments, industries, and consumers will be key in realizing the full environmental potential of electric mobility.